To all of you, welcome back to Resultant AG YouTube channel, where I'm live again with you guys, and I'm back again with some most expected questions of mechanical engineering with my game changer series. Yes, the series will be game changer for RRB JE 2024, as the questions that will be discussed and practiced through this session will make you so much confident about the mechanical engineering subjects, that especially the subject that I am teaching you right now, because my subjects are thermodynamics, applied thermodynamics and fluid mechanics, that when you go into the exam and you see these questions, you will feel so much confident that you will be able to solve those questions. So that is the objective of today's session. First of all, good evening to all the dear students. Welcome. Please tell me if my audio and video is fine. Hello MS, good evening. Welcome to a session. Oh my God. I have just received, you can see, I think all of you can see this message, that as you know that tomorrow is Teachers Day on 5th September, and so a very important offer we are providing you for 5th September on Teachers Day from all the teachers, from all the resultant family, is we are providing 60% discount or 60% off on all our courses. So whether it is RRB JE Focus batch, CBT 1 batch, or it is AIM batch for CBT 2 or Mission batch for CBT 1, CBT 2, you can get 60% off on all our courses. So hurry up guys, offer is valid only on 5th of September, that is tomorrow. Okay, so that is a great information. I think that will be helpful for all the students, and I want you to share it also. I can see there are 7 students live in the session, but this number is very less. I request everyone to quickly share the session. Yes, come on, all the mechanical engineers. These are the only mechanical engineers or diploma students preparing for RRB JE. Come on everyone, quickly share and like the session. And if you have joined this YouTube channel for the first time, then there is a subscribe button. You can click that and you can subscribe to our YouTube channel and press the bell icon which is close to the subscribe button. Also, please like and share the session. See, why I'm saying like and share the session. First of all, you have to share the sessions to all the friends who are preparing for RRB JE exam, who are new and they don't know about this YouTube channel, because as you can see, there are 840 subscribers on this channel. We are providing you quality content, technical and non-technical, for RRB JE, right? And still, if there are 840 students, that is a very low number. I want you to quickly subscribe the channel if you have not done yet, and also share and like the session. My dear students, let me tell you about something about myself. I'm a faculty of mechanical engineering. My name is Vikas, having over 7+ years of experience teaching for different competitive exams like GATE, engineering services, and different AE and JE exams, particularly SSC and RRB JE. And because these are center level exams, and I have mentored for RRB JE 2019 also, and SSC JE from the last 7 years I have been teaching. These are the subjects that I will be teaching you, okay, that you can get knowledge from my side, okay. So yes, second information for you guys is that there is a scholarship test that is going to be conducted on 7th and 8th of September. You can attempt this scholarship test and you can get discount. If you perform well in the scholarship test, you can get great discount on 7th and 8th September if you perform good in the scholarship test. But for tomorrow if you basically purchase our course, any of the course, whether it is AIM batch of RRB JE, tomorrow, or it is Mission batch, if you purchase these courses for RRB JE 2024, then you can get 60% off. 60% off, okay, tomorrow, that is on 5th of September. So this is a great information. I think if you have not yet taken the course of Resultant, you can give it a try, okay. Whatever is the price, you can get 60% off, okay. So let's come to question number 1. I think I have shared all the information with you guys, and my request is that if this information looks important for you guys, so you can also share this information with your friends so that they can also get benefit from it. If you feel that some other students who is in need of these courses, okay, so you can share this information. Question number 1. For a steady flow process from state 1 to state 2, enthalpy changes from H1 is equal to this to H2 is equal to 100 and entropy changes from 1.1 to 0.7. If the surrounding temperature is 300, what is the, neglecting the change in kinetic and potential energy, what is the change in availability? First of all, what is the meaning of change in availability? The change in availability is, change in availability. What is the meaning of change in availability? It is basically equal to maximum useful work. Maximum useful work. Change in availability is also called as maximum useful work. And for a steady flow process, the maximum useful work is given by H1 minus H2 minus T naught of S1 minus S2. So by using this equation, you can find the value of the maximum useful work, which is the change in availability. All right. So here they have given already 400 minus 100. These values are given. Just put these values. T naught is the surrounding temperature. S1 and S2 is also given 1.1 minus 0.7. If you solve this, you will get 180 value. Are you all getting this value? 180. Yes, come on guys. Just 5 students. Great number. I think if this is the percentage of the students whom I have taught so far, just 5 students live in the session. Great number. I am so impressed, guys. So much impressed. Yeah, just a second. Okay. Next question. Going to next question. In a simple impulse turbine, the nozzle angle at the entrance is 60 degree. What is the blade speed ratio for maximum diagram efficiency? Simple impulse turbine, also called as D-level turbine. D-level turbine. And for D-level turbine, the nozzle angle at the entrance, this is the nozzle angle at the inlet, that is equal to 60 degree. What is the blade speed ratio for maximum diagram efficiency? First of all, what is blade speed ratio? Blade speed ratio of an impulse turbine is equal to ratio of the blade speed to the speed of the jet, which is equal to cos alpha by 2 for maximum blade efficiency. For maximum efficiency of the blade, this is equal to cos alpha by 2. So blade speed ratio is equal to cos alpha by 2 and alpha is given to you, that is cos 60 degree by 2. If you know the value of cos 60, which is how much? 0.5 by 2, that is 0.25. Clear? So the right answer for this question is option A, 0.25. I hope all of you have got the answer. Remember this concept, remember this formula. Cos alpha by 2 is the value of blade speed ratio for maximum efficiency of a simple impulse turbine. Next question. If the sum of world components of the velocity at the inlet and outlet of a D-level turbine is found to be 1200 and the mass flow rate of the steam is 15 kg per minute, then the tangential force acting on the blade is. What is meant by tangential force? So as you know that they are talking about simple impulse turbine. Simple impulse turbine, also known as D-level turbine. So for simple impulse turbine, D-level turbine, the tangential force which will be acting, that will be equal to mass flow rate into VW1 plus VW2. Just put the values, you will get the answer. Mass flow rate is 15 kg per minute. So divide by 60 into the sum of the blade velocity. Sum of the world velocity is already given. That is directly given to you 1200. Okay. So 15, 4 is 60. Solve it, you will get 300 Newton. So right answer will be option C, 300. Are you all? Yes. Understood everyone? So this is how you will be able to solve the tangential force on the blade in the impulse turbine. Pascal's law states that pressure at a point is equally transmitted in all direction, or it is equally transmitted in all direction. Suppose there is a static fluid. Do you know what is static fluid? The fluid at rest. So for a static fluid, if you see any, let's say this is a fluid particle. So on this fluid particle, the pressure imparted in any direction, the pressure which is imparted in the x, y and z direction, okay, that is same, that is equal. So for any molecule of, for any fluid which is in a static fluid, static means the fluid at rest, okay, Pascal's law states that the pressure at any point in a static fluid is equally transmitted in all the direction. So that is your Pascal's law. This question came in 2019 of RRB JE, shift 1. Obviously we are talking about CBD2 of RRB JE. So that is important. For a submerged plane in a liquid, the resultant hydrostatic force F on one side of the plane is related to area A, centroidal depth h bar and depth of the center of pressure HCP and depth of the bottom edge is HB. So basically they are asking what is the formula for hydrostatic force. Hydrostatic force for a submerged plane. So hydrostatic force is basically force of the water on a static fluid. That hydrostatic force will be equal to, force is equal to pressure times area, okay. Pressure is equal to what? Rho GH. But here there will be not, it will not be H, it will be H bar, centroid into A. So the right answer will be, what is rho into G? Rho into G you can write it as this, gamma, that is equal to specific weight. So the answer will be option B for this question. Next, a pitot static tube is used to measure the velocity of the water in a pipe. The stagnation pressure head is 6 meter and the static pressure head is 5 meter. The velocity of the flow is, you have to determine the velocity of the flow from the pitot tube. So pitot tube is a tube, you know that it is a tube, glass tube bent at 90 degree like this. The purpose of the tube is to find the velocity of the fluid in a pipe or in an open channel. Okay. So this pitot tube will give you the velocity that is equal to under root 2gh. But if they have given the coefficient of velocity, it will be CV under root 2gh. CV is already given 0.98 under root 2 into 9.81 into h. Now what is h? H is basically, h is equal to difference of stagnation pressure head with the total head minus static head, static pressure head. Okay, so that will be equal to what? 6 minus 5, so 0.98 square root of 2 into 9.81 into 6 minus 5. Solve it, you will get the answer. What value you are getting? Tell me. Yes, everyone, try to solve this question and get me the answer. Oh, it will be 4.34. The right answer will be 4.34. I hope all of you have got this value, right? Okay, very good. Next question. The shear stress developed in a lubricant oil having viscosity of 9.81 poise filled between two parallel plates which are 1 centimeter apart and moving with a relative velocity of 2 meter per second. So basically they are two parallel plates and they are having a relative velocity of the parallel plate is 2 meter per second. The distance between the two plates is 1 centimeter. Okay. Relative velocity is equal to 2 meter per second and distance is dy is equal to 1 centimeter, that is 0.01 meter. All right. Dynamic viscosity is equal to 9.81 poise, which is 0.981 Pascal second. You have to find the shear stress. Shear stress you can find as mu du by dy. Newton's law of viscosity will apply here. Mu is 0.981, du is 2 by 0.01. Solve it, you will get the answer. This is Newton's law of viscosity. We'll apply the Newton's law of viscosity and you will get the right answer for this question. So you will get, just a second. I think there's a mistake. It is coming out to be 196.2 Newton per meter square. So either there is a mistake of some decimal places. Are you all getting this value? Or have I done some mistake? 196.2 it is coming. I think there is some mistake. Either the mistake is here somewhere. It is either, so there can be some mistakes, like either this will be 20 or this should be 10 centimeter or this should be 98.1 Pascal second, because the answer is coming out to be 196.2 Newton per meter square, not 19.62. So there is definitely some mistake somewhere. It is a mistake, but see, ideally what you should remember is the concept. If you are strong on concept, doesn't matter if there is some problem with the values. Okay, so 10 centimeter, either this should be 10 centimeter or this should be 20 or this should be 98.1, then only you will get 19.62. okay, that is you have to multiply with, not multiply, divide. So I'm saying wrong. Clear? So this will be 19.62, not 19, but somewhat around this, somewhere around this. There's some mistake definitely here. An engine at full load delivers 200 kilowatt of brake power. It requires, so what I can do in this question? Nothing. You just remember this formula. If the values will be correct, you will get the right answer. Okay. An engine at full load delivers 200 kilowatt of brake power. It requires 25 kilowatt to rotate it without fuel at the same speed. The mechanical efficiency at half load is, first of all, the concept part. At full load, the brake power is given. At full load, the brake power is given to you as, the brake power is equal to 200 kilowatt. It requires 25 kilowatt to rotate without fuel at same speed. What is this? This is known as friction power. Okay. How much power is required to rotate without at full load, without fuel at same speed? That is called as friction power. Okay. So basically they are talking about friction power right now. Just a second. So this is friction power. They have to find mechanical efficiency. Now, problem is mechanical efficiency you don't have to determine at full load, at half load. What happens at half load? When the load is reduced at half load, what happens? The power, the brake power becomes half. Brake power becomes half. Okay, it just becomes half, that is 100 kilowatt. What happens to indicated power? Indicated power at half load will be, what is the formula for indicated power? It is brake power plus friction power. Brake power at half load is 100. Friction power will be, see, friction power is not affected by load. Friction power is not affected by load. It has no relation with the load. It is affected by the load. Indicated power is affected by the load. So this will be constant. So it will be 125 kilowatt. Now mechanical efficiency at half load you can easily determine. This will be brake power at half load divided by indicated power at half load, which is 100 by 125. Okay. Solve it and tell me the answer. Just a second. think there's some internet connection problem, or everything fine? Just a second, let me just check. Yeah, internet is fine. It looks fine to me. Okay, so if you solve it, you will get 80%. Very good. Option A. Next question. While calculating the specific enthalpy of the wet steam, which of the following quantity is no use to us? When we calculate the specific enthalpy of the wet steam, see, wet steam is in which region? This is a region of wet steam. Okay, this is a region of wet steam, two-phase region, wet steam region. So for calculating the specific enthalpy of wet steam, don't know what's the problem with my connection. So calculate the specific enthalpy. What is the formula for specific enthalpy of the wet steam? It is equal to specific enthalpy of the saturated liquid plus dryness fraction into specific enthalpy of vapor minus liquid. You can use this formula, but in this formula you don't require the value of specific volume. Do you require a specific volume? No, it is of no use to us. So the right answer will be, just a second. Is there some network issue, internet issue? Just a second, let me check. Yeah, is it fine to everyone? Or is there some problem with the internet? Just a second. Looks like there's some problem with the internet. It is connecting and disconnecting. Good evening, Ramjivan. Good evening. Welcome to the session. Is internet fine? Is everything is fine? Okay, all right. Looks like that there's some problem with my mobile phone. Next question. As discharge of 90 liter per second is obtained from a centrifugal pump, which has 20 meter per second tangential velocity at the outlet against a net head of 15 meter. If the manometric efficiency of the pump is 80%, then approximate velocity of the whirl at the outlet of the pump will be. Okay, thank you so much for your response, guys. I'm so happy to know that internet is fine. Thank you for your response. So in this question they are asking the velocity of the whirl at the outlet. This is called velocity of the whirl. They have to find. Thank you for your response, guys. Thank you, Rajesh Sangati. Your name is good, Rajesh Sangati. So there are two people in your name, Rajesh and Sangati. यानी राजेश की संगति करनी चाहिए. You should make friendship with Rajesh. Okay. So what is manometric efficiency? Manometric efficiency is equal to U2 divided by VW2 into U. One second. It is G into HM divided by VW2 into U2. This is the formula, if you remember. Now, if you don't know this formula, then there will be a problem. This is the formula for manometric efficiency. In this formula, the tangential velocity U2 is given as 20 meter per second. The head is given to you as 15 meter. Okay, G you already know, so you can find the value. You can find the answer. It is 0.8 is equal to 9.81 into 15 divided by VW2 into 20. From here you can find the value of VW2. Okay. It has been very long time when I have read this formula. So guys, you can also verify it, whether this formula is right or wrong. I'm just kidding. you will get word velocity as 9.19 meter per second. That will be 9 meter per second. Clear? So this is the formula, and here the discharge value is just given to confuse you. You don't need this discharge value. It is not important. This is a data which is extra data. Okay. Where is Kuldeep? Yeah, Kuldeep is not there. So many students are not there. I think many of the students are not following the classes. There was a reason why I have scheduled the class timing to 8 p.m. so that all the type of students, whether they are in a job or they are a college going student in the final year, they all can basically come in the classes. But the number, seeing that these numbers, 4 to 5 numbers, makes me very sad that where have all the students gone? Where are all the students? You have to find the specific steam consumption. The unit is wrong. It will be kg per kilowatt hour. Kg per kilowatt hour. Kg. Okay. First of all, the unit was given wrong. Specific steam consumption will be specific steam consumption. The formula for specific steam consumption is equal to 3600 divided by net work. What is net work? Net work is equal to work of the turbine minus work of the pump. That is the net work of a steam power plant. Turbine work is equal to enthalpy at the inlet of turbine minus enthalpy at the exit of turbine minus pump work, which is 50. If you solve this, you will get 3600 divided by 1150. You can solve it and you will get the answer. What answer you are getting? Are you all getting this value? 3.13. It will not be exactly 3. It will be 3.13 kg per kilowatt hour. Okay. Clear? Next question is, 2 moles of oxygen are mixed adiabatically with another 2 moles of oxygen in a mixing chamber so that final total pressure and temperature of the mixture becomes same as that of individual constituent at their initial state. The universal gas constant is given as R. The change in entropy due to mixing per mole of oxygen is given by. Looks like it's a very difficult question, but whenever you have to solve these type of questions, adiabatic mixing of two gases, So if there is adiabatic mixing of two gases, okay, the final total pressure of the mixture, 2 moles of oxygen are mixed adiabatically with another 2 moles of oxygen, in a mixing chamber so that final pressure and temperature of the mixture becomes same as that of individual. Change in entropy due to mixing per mole of oxygen. Per mole of oxygen, they have already seen. What will the entropy change? Yeah, mixing will definitely increase the entropy. See, for gases, you know this formula. Okay, this is formula, that is Cp log T2 by T1 minus R log P2 by P1. Okay, you know this formula, but here this formula will be applied or not? The question is, will this formula will be applied here? Some of you are giving option as 0. Will the answer will be 0? Yes. Do you think that entropy will be 0 if mixing take place? Do you really think so? Now, which formula will be used to find the entropy of mixing? Tell me, which formula will be used? So this is a different concept actually. So in this particular concept that you are talking about here, in this particular case, your answer is correct. It will be 0. This formula will not be used. The formula that will be used in this particular case will be mixing of gases. Whenever mixing of gases take place, the entropy change you can find by using this formula. Hello Pushpin, good evening, welcome to a session. And that formula is R, universal gas constant, into N1 log of P1 by P plus N2 log of P2 by P. Okay. Now, as you can see this, what is P1 and P? Just a second, just a second. What is P1? Looks like all the gadgets are creating problem today. Yeah. What is P1? P1 is the initial pressure. Okay, P1 is the pressure of gas 1. Pressure of gas number 1. P2 is the pressure of gas number 2. But here it is saying that the final total pressure, and P is the final pressure. And they are saying in this question the final pressure, that is P, becomes equal to P1 and P becomes equal to P2. So if it's like that, then this will become what? This will become log 1. This will become log 1. And what is log 1? Log 1 is 0. Log 1 will be 0. So this will be 0. So this will be universal gas constant into 0. This answer will come out to be 0. Clear? So that's why the answer will be 0 in this case. What is defined as saturated steam always exists at the temperature of the boiling point corresponding to that pressure. What do you call this type of steam? What is the name of the steam which exists at the boiling point corresponding to given pressure? Steam at the boiling point. First of all, boiling point is also known as saturation temperature. Steam at a given boiling point, that is also called as, see, this is called as saturated water. Here we have saturated water. Here we have saturated steam. Okay. Steam at the boiling point, that will be your, yes, will it be wet steam or dry saturated steam? They are already saying that saturated steam always exists at the temperature of the boiling point. That is called dry saturated steam or simply saturated steam, because they are already saying it is a saturated steam. And that saturated steam which is at the boiling point, that will be your dry saturated steam or simply saturated steam. Okay. A gas is contained in a cylinder with a movable piston of 100 kg mass. When 2500 joule of heat flows into the gas, the internal energy of the gas increases by 1500 joule. What is the distance through which the piston will rise? So we are having a piston cylinder device. This is a piston here. Okay, and this is a gas kept in the system. What is happening here? When 2500 joule of gas, this much amount of heat enters the system of gas, this piston whose mass is equal to 100 kg, it will rise. Okay, let's say it will rise to this much distance, it will move to this distance. Let's this distance is equal to d into x, dx. Okay, there will be a displacement of the piston and internal energy of the system will increase. Du will be equal to plus 1500 joule. First law of thermodynamics is Q minus W is equal to du. Apply the first law of thermodynamics. Heat transfer is 2500. This is 1500. So you can get the value of work which will be equal to 1000 joule. Now this is the value of work. Now what is work? How you obtain this work? This is also called displacement work, because this work is obtained by displacement of the system boundary. So this is displacement work which will be equal to force into displacement, which is dx. Okay, and what is the force? Force will be, this is the force. Let's say this is the force acting on the piston. This force will be equal to weight of the piston. Under balance condition, the force will be equal to weight of the piston, which is equal to mg. So you can say 1000, which is the work, is equal to m into g into dx. 1000 is equal to, mass is 100, g is 9.81 into dx. From here, if you solve this, you will get 1 meter. This is the amount of displacement. Clear? 7 to 8. This is scholarship test. Yes, Subhadeep. The scholarship tests on 7th and 8th will be for JE. Yes. But tomorrow on Teachers Day, we are providing you 60% discount on all the courses. On all our courses, whether it is for JE or any other exam, we are providing you 60% off. Fill out the Google form. Yes. One more thing, there is a Google form which is pinned in the description of this video. You will find a Google form. In that Google form, if you submit your details, we will definitely be taking a session on how to, that will be a guidance session on RRB JE. Okay, or if you want any type of guidance for RRB JE, you can fill out that form. A simple Rankine cycle produces 40 megawatt of power, 50 megawatt of process heat, and rejects 60 megawatt of heat to the surrounding. What is the utilization factor of this cogeneration plant? Subhadeep, I think I have not asked about this. I'm sorry, but what I think is it will be non-technical only, because it will be common, because first exam will be non-technical exam in CBT1. So I think it will be non-technical based, so that those who will perform, it will be common for all. If you perform well, you will get discount. See, utilization factor for a cogeneration plant. What is cogeneration? But let me just, I will also ask about this. Okay, I will confirm this with my team, but I'm 90% sure that it will be non-technical. Okay, it is equal to work output, the output work that you get, plus that is the process heat that is utilized, divided by total heat is the work output plus process heat plus the heat which is rejected. So just put the values. The power output is 40, the heat spent in the process heating is 50, divided by 40 plus 50 plus 60. If you solve this, you will get the right answer. Okay, 40 plus 50 is 90 by 150. So you will get 60%. One more thing, what is cogeneration? What is cogeneration plant? Now cogeneration plant is that plant where the total steam that is produced, the heat of the steam will be used for two purposes: for power generation, that is electricity generation, and also that will be used for some process heating application. Process heating means there are some processes in the industries where we require the heat of the steam for carrying out some process. So that kind of plant is called cogeneration plant or cogeneration steam power plant. There are many sugar industries also where the steam is used for generation of electricity also and for process heating also. Okay, there are many examples of cogeneration plant. So for any cogeneration plant, if you have to find utilization factor, Just add the output work and process heating, divide by total, whatever is given. Using an engine of 30% thermal efficiency to drive a refrigerator having COP of 5, what is the heat input into the engine for each megajoule of heat, megajoule heat removed from the cold body by the refrigerator? If you remember, this similar type of question we have, I think, solved in the previous session, but in that question this data was not given. Here they are asking what is this heat. Okay, now you understand this concept that whatever will be the work output for the engine, that will be the work input to the refrigerator, and by taking this work input, the refrigerator will do what? It will take the heat from this cold body. How much heat? 1 megajoule of heat it will take from the cold body, which is at low temperature, and reject the heat to the high temperatures, that is surrounding. Okay, so the concept, it will be this. Now based on this concept, they are saying 30% efficiency is there. The efficiency of the heat engine is equal to 30%, which is 0.3, which is work output divided by heat input. Heat input is Q1, so work output will be equal to 0.3 into Q1. That is also equal to work input. Now COP of the refrigerator is equal to 5, which is equal to desired effect. What is desired effect? 1 megajoule, which is 1000 kilojoule divided by work input. Now work input is equal to 0.3 of Q1. So 1000 divided by 0.3 of Q1. If you solve this, you will get Q1 is equal to 1000 divided by 5 into 0.3. If you solve this, you will get 666.67 kilojoule. Okay, are you getting this value? Tell me. Are you all getting this value? So we have solved a similar type question. And one more thing, that if you have joined this session and you have not, those who have not liked the session and shared the session, please do it. Take out few seconds to, if you think that the questions we are discussing here will make your preparation better, are helping you in your preparation. If you find this session useful, then you can also take out few seconds to like and share the session. In a given process of an ideal gas, work is equal to 0 and heat transfer is negative. Then for the gas, what can be said about temperature and pressure? First of all, work is 0. Pressure will remain constant? No, because pressure, if a pressure is remain constant, there is some work for that gas, that is pressure into change in volume. So we cannot say that pressure will be constant. Work is 0, that is only for constant volume process. So this becomes wrong. If the work is equal to 0, then according to first law of thermodynamics, the heat transfer will be equal to change in internal energy. And if heat transfer is negative, that means internal energy will be negative. If internal energy is negative, then temperature will reduce. So temperature will decrease. Clear? So right answer is option A. Next question. A reversible engine exchanges heat from 3 thermal reservoirs. We have 3 reservoirs, and which are basically represented as A, B and C. They are at temperature of 1800 and 200 Kelvin respectively. If the engine receives 500 kilojoule of heat from A and 400 kilojoule of heat from B, then what is the heat exchange from thermal reservoir C? Now this question may look very tough to you, very difficult for you to understand. Okay, I can see few more students. I think they are new students. So welcome everyone, those who have joined me for the first time. So these are 3 bodies. Okay, let's say this is A, this is B. These are the 2 sources. And obviously the third body, which is denoted at C, the heat is ejected to the third body. They are basically, they have given that the temperature third body is, that is the sink is 200, this temperature is 800 Kelvin, and this is at 1000 Kelvin. This is a heat engine, it will definitely give out some work output. The heat input QA is equal to how much? How much heat is taken from A? That is 500 kilojoule. How much heat is taken from B? That is equal to 400 kilojoule. You have to find what is QC, heat rejected to the low temperature. Now this question may look very difficult to you, but it's very easy question. How it is easy? For reversible engine you all have studied. According to Clausius inequality, cyclic integral of Q by T equal to 0. If you apply this, you can write QA, which is the heat supplied, divided by TA plus QB by TB minus QC by TC equal to 0. Why minus? Because this is a heat rejected and these two are heat supplied. Apply this, you will get the answer. You solve it, you will get QC. What is the value of QC? Tell me everyone. Yeah, from Clausius inequality you can solve this question. It will be 500 divided by 1000 plus 400 divided by 800 is equal to QC by 200. Solve it, you will get the answer. Okay, so when you solve this, you will get 200 kilojoule is the amount of heat which is rejected. Clear? Next question. An engine reversibly receives 1200 joule of heat at 900 Kelvin. After rejecting the heat to the ambient at 300 Kelvin, it develops 600 joule of work. You have to find the irreversibility in the joule. What is the value of irreversibility in joule? So if you see this engine, this particular engine is receiving how much heat? It is receiving the heat of 1200 joule. And this engine is at 900 Kelvin. And the ambient, that is surrounding, is present at 300 Kelvin. Okay. It is one more thing that is important for you to notice. Ambient. This is ambient. Ambient means surrounding. This is the surrounding temperature. If the heat is rejected at the surrounding temperature, then the work which will be obtained, that will be maximum useful work, which is exergy, or it is also the available energy. Okay, because the engine is a reversible engine. Reversibly means it is a Carnot engine, reversible engine, and this reversible engine is rejecting the heat to the surrounding. That will, it will produce maximum useful work. Okay, or it will produce available energy. This available energy is equal to 600 joule. Now question is how to find the irreversibility. Very difficult question, you know? Very difficult question. So what is the meaning of irreversibility? You must have understood the concept. You must remember this concept. Total energy is sum of available energy plus unavailable energy. Total energy has basically both the things. It has available energy or unavailable energy. Okay. Unavailable energy is also known as irreversibility. Now what is total energy? Total energy is this. The total heat 1200 joule. What is available energy? It is 600 joule. What is irreversibility? You have to determine. So can you solve this irreversibility? That will be 600. Simple. Clear? Are you all getting this? It will be simply, you don't have to even use your, without using your pen also you can solve this question. That means not too much of calculation is required for solving this question. Clear? How many of you understood this question? Next, which statement is or are correct? Carnot cycle is a reversible one, or it is a reversible cycle. All the reversible cycle have same efficiency. Just a second. All the reversible cycle have same efficiency. Carnot cycle has maximum efficiency in all the cycles. A reversible cycle has more efficiency than an irreversible one. So which will be the right answer for this question? Carnot cycle is a reversible one, that is correct. Carnot cycle has maximum efficiency in all the cycle, that is correct. All reversible cycle have same efficiency, that is also correct. Reversible cycle has more efficiency than irreversible, that is correct. Here all the options are correct. Okay, but here is one thing that is important for you to understand, that the right answer can be option C also for this question. Because these two statement, and not only C, right answer should be option B. अजय से इसका आंसर सिर्फ एक ही होना चाहिए, only option B. Okay, only option B should be the right answer. Why? Can you tell me why? As per the options, the answer should be option B, only one. Why? Because these are two Carnot principle. These are two Carnot principle. These two statements are Carnot principle, that all reversible cycle have same efficiency between same temperature limits. This is not mentioned, same temperature limits. Reversible cycle has more efficiency than irreversible between same temperature limits. This is not mentioned. But the problem is even if it is not mentioned, that means if you say this is wrong, what about the third statement? Carnot cycle has maximum efficiency in all the cycle. That is correct. Carnot efficiency has maximum efficiency because Carnot cycle is a reversible cycle. So it will be having maximum efficiency. That is not wrong. Okay. So that is correct. So this is correct. So 1 and 3 is not the right answer. So what we have to do for this question, we have to assume same temperature limit. Because if you don't assume, you cannot write only option 1, because Carnot cycle has maximum efficiency in all the cycles. That is correct. So that is why the answer will be, after doing this assumption, you have to mark option D. Okay. So remember that there is some assumption you have to make, and that has to be made. Why? Because if you don't make this assumption, you will not get any right answer. If you only say Carnot cycle is a reversible one, that is half correct. Okay, so we have to assume same temperature limits for these options. A closed system of constant volume experiences a temperature rise of 50 degrees Celsius. When a certain process occurs, the heat transfer in the process is 100 kilojoule. The specific heat at constant volume for the pure substance comprising a system is 1 kilojoule per kg degree Celsius, and system contains 3 kg of this substance. Work done in this case is. How can you find this work done? First of all, we need to understand a closed system of constant volume experiences a temperature rise. See, temperature rise is there, although the closed system has constant volume. Volume is constant for closed system. So what you will think? You will directly say, sir, work will be 0. Will you say this? Sir, well, work will be 0. But here is no 0 option. There is no option 0 given here. So what we have to do? This is the boundary work. Boundary work will be 0, or non-flow work will be 0. Non-flow work will be 0. Or closed system work will be 0. But your system can do any other type of work also. It's not that there is only one option of doing the boundary work, closed system work. Okay. So what are the other options? The other option is that, just think about it. If there is no work done, then why temperature is increasing? There will be some reason that some temperature is increasing. So maybe on your closed volume system, some other kind of work is happening, and that other kind of work will be, maybe electrical work is done, maybe it is not mentioned, maybe electrical work is done, maybe some other work is there, because this is increasing the internal energy which is equal to mc delta T. This is getting increased, which is 1 into 3 into 50. Okay. So internal energy is increasing in this case. So you will get 150 internal energy. All right, plus 150. And heat is transferring the process 100. So heat transfer is equal to 100. So what should be done here? Let's say the work is there, and that work is work input obviously. So Q minus W is equal to du. Q is equal to 100 minus work is equal to du, which is 150. So work will be equal to 100 minus 150. That will be minus 50. Work should be minus 50 for sure. Okay. So the answer will be option C, minus 50. Because there will be some input work. But that work is necessarily not the boundary work, because boundary work will be 0. But here can be other work also. And some other work is definitely done. Otherwise, why temperature is increasing? Temperature is increasing because of some work only done on the system. And it is work done on the system, that is why there is a minus sign. In which of the following process in a closed system, the thermal energy transferred to a gas is completely converted to internal energy, resulting in increase in the gas temperature? The heat transfer, thermal energy is nothing but heat. The heat transfer is completely converted. It is completely converted to internal energy. It is completely converted to internal energy in which process? Only for constant volume process this is possible. Why? For constant volume process, work transfer is equal to 0 for closed system. So if work transfer is equal to 0, then heat transfer will be equal to change in internal energy, that is isochoric process. Clear? Is it clear to all of you? Option A, isochoric. Isochoric means constant volume. Next question. An ice plant is to be maintained at 270 Kelvin. The ambient temperature is 300 Kelvin. If 5 into 10 to the power 6 kilojoule per hour of energy is to be continuously removed from the ice plant, the minimum power required to run the refrigerator will be. So we are having a refrigerator. And this refrigerator is operating between these two temperatures, 270 Kelvin temperature and 300 Kelvin temperature. This much amount of heat is getting removed, 5 into 10 to the power 6 kilojoule per hour. What is the power input? You have to determine the power input. Question is very simple. Firstly, you have to find the COP of the refrigeration system, which will be this. Okay, 270 by 300 minus 270, that is 30. You will get 9. Now this COP is equal to desired effect, which is 5 into 10 to the power 6. It is kilojoule per hour divided by 3600 divided by power input. If you solve it, you will get the answer. COP is 9. Solve it. If you solve it, you will get the right answer. Tell me the right answer for this question. Tell me, everyone. You will get power input as 154.3 kilowatt. Okay, option D. Clear? Is it clear to everyone? Understood? Next question, last question for today's session. This is the last question. Hello Ravi Ranjan, how are you? Good evening. I was about to say good morning. Good evening. Welcome to the session. A heat engine receives 1 kilowatt of heat transfer at 1200 Kelvin and gives out 600 watt as work, with the rest as heat transfer to the ambient at 300 Kelvin. You have to determine the second law efficiency of the engine. सर आपका क्लास अब यहाँ होती है क्या सर और कितने बजे? Yes, Ravi Ranjan. This is a new platform where I am teaching right now, and I'm also sharing the class link in the Telegram, my previous Telegrams. 8 p.m. is the time for YouTube session. Okay, so I will be coming here daily at 8 p.m. and you can join this YouTube channel and you can watch my classes. You can see the classes. So first of all, what is second law efficiency? second law efficiency is equal to the actual efficiency divided by Carnot efficiency. You can also call it as first law efficiency divided by reversible efficiency. How to find the first law efficiency? First law efficiency is equal to work output divided by heat input. Work output is 600 watt. Heat input is 1 kilowatt. That is 1000 watt. If you solve it, you will get 60%. 60% is the first law efficiency. Carnot efficiency depends on temperature, that is 1 minus 300 by 1200. You will get 75%. So actual efficiency is 60%. Carnot is 0.75. You solve it, you will get 80%. So 80% will be the answer. And when do you use this formula? This formula is only used when the actual efficiency is less than the Carnot efficiency. Only then we use this formula of second law efficiency. Okay, and in this case you can see that actual efficiency is less than Carnot efficiency. So these were few questions. Rest of the questions will be I will take in the next class. I want to tell you very important information that these are the RRB JE batches, 3 batches of RRB JE right now. Focus batch for CBT1, AIM batch for CBT2 and mission batch for CBT1, CBT2. These are the prices. And if you are having any query, you can just call here or mail here. Tomorrow on Teachers' Day, since tomorrow is Teachers' Day, so we are providing you a discount 60% off on all courses. Okay, flat 60% off on all the courses. Tomorrow, that is 5th September, only for tomorrow. And on 7th and 8th September, we are organizing a scholarship test. On 7th and 8th September, you can give the scholarship test, and if you perform well, you can get good discount on our courses. Please do not forget to subscribe our channel and press the bell icon close to it. Share this session so that students like Ravi Ranjan is saying that, sir, मुझे नहीं पता था क्लास यहाँ पे होती है. So that the students who are not informed about this YouTube channel, they can also get informed and they can also join these classes. And if you like this session, then please do not forget to like it. I'm going to see you tomorrow at 8 p.m. All right, with my set of questions on thermodynamics and fluid mechanics and applied thermodynamics. Thank you so much. Have a nice day. I will see you tomorrow again with some amazing set of questions. Thank you so much. Have a nice day.